Good day viewers, you are welcome to my YouTube channel. This is Chem Easy and I'm Echo Jeremiah. Today I'll be doing a brief experiment on NECO 2022 chemistry practical, the qualitative aspect of it. So please, if you've not subscribed to my YouTube channel, ensure you do that immediately. And also, don't forget to turn on your notification so that you'll be the first to get my videos. Please, a lot has been put into this video to ensure that you get a clarity of the qualitative aspect of it. So please do well to subscribe to my YouTube channel. Thank you. So here is a prediction of how the question will look like. Xn is zinc 2-triazocarbonate 4, Yn is aluminum chloride. So they might be in a separate container and they will ask you to carry out the further analysis. Xn and Yn are two inorganic salts. Carry out the following analysis on Sn and Yn, record the observation, and identify any gas involved. State the conclusion you draw from the result of each test. 1. Put Yn in a test tube and add about 5 cm³ of distilled water. Divide the solution into two portions. To the first, add sodium hydroxide in drops and in excess. To the second portion, add ammonia in drops and in excess. Then number 2, which is Sn, your zinc 2-triazocarbonate 4, put Sn in a boiling tube and heat. Add about 5 cm³ of hydrogen chloride and divide into two portions. To the first portion, add sodium hydroxide in drops and in excess, and to the second portion, add ammonia in drops and in excess. So here are the procedures for the practical. We start with Yn, which is aluminum chloride. So number 1, Yn plus 2 cm³ of distilled water. The observation, it dissolved to give a colorless solution. Inference, Yn is a soluble salt. Number 2, Yn plus litmus paper. It turns blue litmus paper to red. Yn is an acidic salt. Number 3, Yn plus sodium hydroxide in drops. You get a white gelatinous precipitate, and this tells you aluminum ion or zinc ion is present. Then in excess, the precipitate is soluble in excess. So this also tells you aluminum ion or zinc ion is present. Then over to the third one, Yn plus ammonia in drops. It gives a white gelatinous precipitate, and this tells you aluminum ion and zinc ions are present. Then in excess, the precipitate is insoluble in excess. This confirms the presence of aluminum ion. So here are the two salts to be required to carry analysis on. We have zinc 2-triazocarbonate 4 and aluminum chloride. Zinc 2 carbonate is your Xn, while aluminum chloride is your Yn. So the first thing we'll do, we'll make an aqueous solution of Yn with distilled water. We found out that Yn dissolve in it in distilled water, so Yn is a soluble salt. And then we'll go further to test with blue litmus paper. You observe that it turns blue litmus paper red. There from the inference, Yn is an acidic salt. So you divide into two portions. Now to the first portion, you add caustic soda, which is sodium hydroxide, in drops and then in excess. You observe a white precipitate is formed in drops, and in excess it dissolves to give a colorless solution. Then we'll go further to test with ammonia. With ammonia in drops, it also gives a white precipitate. and it is insoluble in SS. So here are the procedures for the prediction of SN. XN plus heat, you observe the residue will change from white to yellow when hot and then turn back to white on cooling. They will know XN is either zinc 2 carbonate or zinc 2 nitrate. Then number 5, XN plus heat plus calcium hydroxide, which is lime water. You observe an effervescence of a colorless and odorless gas which turns lime water milky. This tells you the presence of carbonate. And number 6, XN plus dilute HCl. It dissolves to give a colorless solution. Number 7, XN plus sodium hydroxide in drops. A white gelatinous precipitate is formed. Tells you aluminum ion and zinc ions are present. Then in SS, the precipitate is soluble in SS. This also tells you aluminum ion and zinc ions are present. Then the last one, number 8, XN plus ammonia in drops. The white precipitate is formed. Also aluminum ion and zinc ions are present. Then in SS, the precipitate is soluble in SS, and this confirms the presence of zinc 2 ion. Alright, we'll go for that text for XL, which is zinc carbonate. Now the cation here is zinc, while the anion here is carbonate. So we'll test for zinc and we'll test for carbonate. First, you will be asked to add a spatula full of zinc carbonate into a boiling tube. And you'll be asked to heat for a while. Now you observe, if you heat it, the color will change from white, this is white, to yellow when hot and back to white when cold. Now the gas above, the effervescence of the gas, if allowed to pass through lime water, it will turn the lime water milky. So we'll have to do a little connection here by adding this. So it's just that we're carrying two tests here. First we heat, it turns from white to yellow, and when you're allowed to cool, it turns back to white. And the gas above here will be passed through lime water, and you observe that it should turn the lime water milky. So this is calcium hydroxide, which is lime water. If you check your reagent there, you're asked to prepare. You'll see calcium hydroxide. My next video, I will drop a short video on how to prepare the solution of calcium hydroxide, also known as lime water. So alright, so our connection is set. So we'll eat now. Just watch and see. So you observe as it's boiling, it's decomposing to give you zinc oxide and carbon 4 oxide gas. Now the effervescence of this gas, when passed through lime water, it turns to lime water milky. And then the zinc carbonate turns from white to yellow when hot and back to white when cold. You can observe the lime water is turning milky now as a result of the effervescence of carbon 4 oxide gas. Now you can see the lime water has turned milky, and then you observe the salt has turned from white to yellow. You can observe the color of the salt, pale yellow. So the next one is your XN, which is zinc carbonate plus HCl. You observe that it dissolves to give a clear solution. And then you divide into 2 test tubes. To the first portion, add ammonia in drops. You have a white precipitate that dissolves in excess. So to the other portion, add caustic soda in drops and then in excess. In drop, also have a white precipitate, and in excess, you see the precipitate dissolve. This confirms the presence of zinc.